Look at what we have here, a big boy box. Let's open it up. I think I know what's inside it. I think it's a Dyson fan. I only bought it yesterday and it's arrived today. Obviously faulty. Ah, packaging peanuts. What on earth is in here? It is. Well, where's the big bit off it gone? I hate packaging peanuts. Right, so it's got the remote control. That's good. That's a bit over packaged, but still, I suppose it's better than it arriving all smashed up. Right, okay, it's incredibly lightweight. Oh, look at all that. What's in here? See, that's annoying that they're just doing that to get rid of their rubbish, you know? Right, and I also found that in it as well. So, let's plug it in and see what it's doing. This is basically an AM07. It's supposed to be a current model, meaning you can still buy it in places like Argos and John Lewis and stuff like that. I just had a look, £350. I paid £75 plus postage. I think it was about £15 postage. So if I can get it working, then it will actually be, it won't be a bad buy. Right, okay, I'm just going to plug it in. Right, I've got it plugged in. Let's see, will it do anything? No, completely dead, which is what the listing said. Okay. Right, let's get it over to the blue mat, check the fuse, and then take it from there. I'm sure it's going to be super complicated on the inside, but there's some screws down the bottom. Let's see, is it just going to be a power supply failure? If it is, would it be fixable or not? This is a trying to fix video. I haven't got a clue whether I'll be successful or not, but fingers crossed I will be. Now, the plug looks just like the Dyson hairdryer that I looked at in another video. Let's pop the fuse out and see if the fuse is okay. 13 amp, looks a little bit burnt here. Now the write-up said it just stopped working. But then again, everything works until it stops. But I suppose it's not intermittent. Right, okay, fuse is all right. So now, pop that back in. Let's see. I suppose we need to start at the bottom side of this. And it could be a motor up the top. Let's start at the bottom and see if we have anything coming out of the board. So we've got a load of what looks like Torx screws around here. Let's undo them all and see what happens. Right, these are all Torx 8. Now everything smells oily. So maybe this has been on in, for example, a workshop constantly. So it might have been on for the last year. Oh, we've got some fancy little connector there. Right, and access there. Access to nothing. So we have to take out this big one here, I think. Right, Torx 20. Well, that looks like a bearing. This bit rotates around it, you know, for the oscillation. Oh, here we go. I wonder, is there more hidden screws under here? I bet there is. There is, isn't there? Yet another sneaky one here. Oh, here we go. Right. That is like a big plate at the bottom with the bearing, you know, like a roller skate bearing or skateboard bearing. So far, so good. Now, how do I take it from... Oh, right, I can see an oscillation thing. I can see like the oscillation thing here. There's like an arm going across here. Problem is I can't get to the screws to undo it. I can see one of them. I'm not going to be able to get to them. How are you supposed to... basically, there's two screws here. And it's holding the arm on, so I can't take this off because the arm's still on. I can't see a way to dislodge the arm unless you just Oh no, there's a circlip here holding it on. Right, let me try to undo that circlip. Doesn't matter if it pings off because it's only going to ping off in here. Basically, if you look in here, you can see that there's a little circlip thing just here. And I need to just try to get it off. You'll see it when it's fully open. There we go, that popped off. Right, now, is this going to lift itself up? Yes, it is. Excellent. Yay, we're free. So, that was the arm there. This thing here, and that was held into this with a circlip. So there should be a circlip, and it's just here. Right, so that wasn't too bad so far. So I'm wondering, is it a problem with this board here? Maybe, and this must go up to a motor. That all looks bent here, that screw. Why would that screw be bent? Let's see if it does back up. Maybe someone's already looked at it. Let's just see. It should be in here, wasn't it over there? It was screwed in over there, wasn't it? It should be in here. What on earth's going on? Why was that screwed into the wrong place? Right, okay, that needs to go on there. You can see the two bits here. Right, I'm not quite sure what's going on there, but let's leave that off for the moment. Now, I want to remove this, so let's undo this plate. Hopefully, we can then undo it from here. I'm wondering if there's a problem with this board here. Let me just take a picture of what's what. And I can see the incoming wires coming in over here. Right, so let's pop that off. Now I've got to be careful here because there's a power supply and I have had it plugged in. So there might be voltage left in that cap. Right, so this is on some sort of rubber plug thing that just goes down there. And now we should be able to unplug this. I've taken a picture. So now, excellent. We are free. So this is going to go up to the motor, isn't it, for the actual fan. I don't know why we need so many wires. I'm not sure what else this does because this one doesn't do heat. And it says cool, but it's not actually cooling anything. It's just a fan, basically. The reason I would like it to work is because I bought a fan from Costco years ago. I don't know if Costco is just a UK thing. Imagine like a place where tradespeople can go to buy their, bulk food and this, that and the other. Problem is, my son loves to have it on in the summer. Even if he's not that hot, he's like, oh, I'm so hot. He just wants it on. But my wife likes everything to be quiet when she goes to sleep. So there's a constant battle between him wanting it on and her wanting it off, even though they're obviously in separate rooms. So with this one, I'm wondering whether it would be quieter than my existing one. So if I could get it working, it would be great. Right, okay, so let's see now. We're going to have power coming in here, and I presume we're going to have power going out here. But even when we turn it on, nothing's happening. So saying that, it's not even getting to that stage there, is it? It's not getting to that stage. So, can I see anything that looks bad? No. I wonder, could it be a problem with simply the on and off switch? But mind you, it should come on with the remote control. Oh, and this motor here is for the oscillation. This one's here. Let's take the board out, just in case I want to measure, see if there's anything in that cap, and see whether this big cap here, and then see if we can see anything obvious on the underneath of it, because all this looks nice. So what do you reckon? Yes or no? Do you think it's going to be repairable? It all looks very nice and clean at the moment, so yeah. Right, anyway, while I'm getting the board out, let's give a shout out to them. My mate Vince Massive, they are the top level Patreons. This month, they consist of kitdigital.com, Kip Hakes, Max Rokotansky, Having Fun Repairs, Will Michaelis, Chris Seal, Felipe at MrKeebs.com, DJ VG, Ellis Garbett, Pigsy, Robert from Timsy's Auto Air, Daniel Watson and Zeke's C. There's people in that list there that have been there for an absolute eternity, which is great because it means I get to make content that doesn't necessarily have to get loads of views. It's nice because you can do a wide range of fixes, even though some of them is going to flop on YouTube. It's still nice to have that option because things like the Tom and Jerry Jack in the Box was never going to be a success. But it's an interesting item, and it's good because you see a lot of people don't do items like that on YouTube because they know they don't get views, and that's what's good about having support like that. It means you can sometimes do interesting items that are not going to get a lot of views. So yeah, massive thank you. Oh, okay, we've got a little display here for, must be to show like the speed or something. Okay, so we can disconnect the motor here, and we can, I'll tell you what, before we do anything, let's measure that big cap, just so I don't get a shock, PlayStation 4 style. No, there's nothing there. So that should be safe to work on. Oh, massive fuse, huge fuse with a weird black bit on the, oh, weird black bit on the side here. Let's see if we've got anything in the fuse. Oh, I thought we had a dead fuse there for a minute. Why is it not going off now though? Oh, it is. Yeah, this board has got a shiny, so there's a coating on this board. Makes it harder to test. Right, the fuse is okay. I wonder why it's black here. No, I don't think there's anything. Okay, right, nothing there. So let's pop this out here and pop these out. I'm just going to take one more picture of that. Right, they're hard to get out, but there's a little, just like on the Rolls Royce, there's a little tab here to press in to remove them. There we go, it's like a lock-in tab. Wow, that was incredibly hard to remove. Okay, so first things first, let's just check that the wires themselves are okay. So let's go from the plug to here. We're going to go to neutral, which is going to be blue, here, and live. Yeah, okay. So we definitely know power's getting into it, so it's not going to be anything to do with that. So power's getting in here, but is power going out of here? So I suppose we need to start tracing where it goes to. The live goes through the fuse. Should we follow the trace off the live wire? Let's zoom in. So we go from the prong to the end of the fuse. Yes, okay, so that's fine. Then from the end of the fuse, it goes through this little resistor up to here, through the resistor, through that resistor, and then it goes, but then the neutral also goes through that same resistor, doesn't it? Okay, then it goes down this way, down here to here, which is going off to that power motor thing for the oscillation. What are these two prongs? These two prongs are going to these things here, varistor maybe, V1, V2. And also up to here, which is this big, that's like one of those, is that a big capacitor to stop interference going back down the line? I think it might be. Right, okay, and then from there, where does it go? I suppose it must go up to the coil surely, but I can't see, so then it's on the neutral, isn't it? Yeah, okay. Coil. Don't know what's in here. RT1. Not sure, but it's all covered up. Tell you what, let's check for shorts on that capacitor. The negative of the capacitor. They're not going to go through the coil down to here? Why am I not getting that here? Oh, is it because it's going through the diodes? Tell you what, let's check the diodes. So this is basically the bridge rectifier, isn't it? convert the AC to DC. Do you know what, there might not be anything wrong with this board. Maybe I should just plug it in and see if we have voltage and just be really careful. Right, let's see what we got going on here. Right, nothing. Something. Nothing. No, again, it's just a conformal coating. Something. Something. Nothing. Something. Nothing. Right, okay. On and off switch. Where are you? So is it this button here? Yeah, so when you press that there, it goes off to the side and it lights up as well. So it's this thing here, and that's the infrared thing. So let's see if the on and off switch is working. That has to be it there, doesn't it? So that's the middle one. And then it's just going to be shorting against, you know, just anywhere, just here. Right, so I'm down to the copper here now. So if I go between here and here, can't be a faulty switch because everything looks nice and clean. Oh, here we go. Yeah, okay. Right, okay, definitely not the switch. So it looks like the switch is okay, and also the AC side of the circuit seems to be okay as well from the little bit of testing I did. So I think I need to put voltage into this to see if we have maybe voltage at the big capacitor, and then that will tell me if there's no voltage there, maybe there's a problem with the bridge rectifier side of the circuit, even though the diodes are testing okay. Obviously don't copy what you see in my videos. It's not safe to work on something when it's plugged in. You can kill yourself from electric shock. I'm not going to be actually touching it with my hands. I'm purely using my multimeter leads, and there's nobody else around me that can reach over and touch this. But as I say again, it's very dangerous. Do not copy what you see in these videos. Okay, here we go. Let's plug it in and see what happens. So I'm plugged in right now. See, is it going to turn on?
Don't worry, Alexa, neither does he.
Right, so there's nothing happening there. Okay, let me use an insulated screwdriver. I'm just going to try to hit the on and off button. No, right, okay, there's no life there whatsoever. So now, let's go on to AC. Let's see, have we got anything on these prongs here that go off to that little motor? We have got 240 volts going into that motor. Wow. Okay, 240 volts going in there. Now we're not going to have any power here, are we? Because it's not turned on. Mind you, over this side it's going to be DC, I presume. Let's go to DC. No. So we've got 240 volts there. I wonder, do we have 200 what voltage? Whether we have like 300 odd volts DC coming out of that cap. How can I test that? I need to turn it over, don't I? Right, let's unplug it. And let's gently turn it over. And now let me plug it back in. Let me measure this cap. Right, what's going on there? Again, is it the conformal coating? So, what I'm going to do is unplug it. I'm going to scrape the contacts. I can't get through the conformal coating, and it's dangerous because one slip and then I'm going to short myself out on that. Right, okay, so I've just scraped along a few of the things here, and I'm hoping now my multimeter will be able to give me a reading. So let's plug it back in. Hands well clear. Let's see now, I'm on volts AC. Yeah, there you go, 244. Right, so we've got voltage there, full voltage going in AC, 240. Let's see this side. 240. Right, okay. Now, what have we got at the capacitor? So if I go to DC, We've got 330 volts. So we've got 330 volts coming out. Where do you go to then? Why are you not turning on? Shall I see what voltage we have on the actual, see if I can get a voltage reading on the switch. So I'm still on DC. It's hard to tell, but it doesn't look like there's anything there. So we definitely have voltage here. Now we've got a load of sort of control chips here. Let's unplug it. Well, it bleeds away the voltage very nicely. Kind of wondering whether the power supply is working okay. But why are we not getting anything here? Right, could it just be as simple as some sort of weird continuity? Let's unplug these again. I didn't plug them in properly, that's why they're so easy to take off. Could it be that there's no continuity between these two boards? Right, okay, they're definitely getting from board to board. Do you know, I'm really struggling here because I can't see any problem. I can't see any blown components. Right, I mean, I'm thinking there has to be a problem here because this is the thing that turns the board on. After this is to do with the motor. So if you had a spare one of these, you would just swap it over and then you've proved it 100%. Let's zoom in and have a look at the components. So we definitely know this side here is okay. Yeah, you see. Right, let's have a little looky. Maybe I'll just go around the capacitors, see if there's like a faulty cap that's putting a short on. Again, it's going to be annoying because of the conformal coating. Just conformal coating, isn't it? I'm going to say right now that I don't think I'm going to be able to fix this. So if you're bored of the video already, you can always skip to the end. And then obviously if I have fixed it, then you can go back, but you're going to spoil the outcome then. Does that look blackened? I'm just going to check for a short across there. No, in the meg ohms there. 5 meg ohms. So I'm just going to do loads of testing. I'm going to test all the caps and stuff, and then if I find anything, I'll start filming again. But I don't think this is going to be a good one for me. Actually, just in case that you know, on and off switch part of the board is faulty, let me just make sure that there is actually power in this battery. Looks like there's a CR2032 or 2025 in here. Here we go. 2032. Now, let's see if you've got anything. Yeah, 3 volts. That's okay. Okay, I haven't got anywhere yet, but I'm just concentrating on the power switch because we're getting no power either from the remote control or pressing the button there. So basically, the power switch does actually work its way down to this point here. So on the through hole little connection, this one here, if you have a listen, if I was to take a ground here and here, second one along and press the button, can you hear it there? Problem is I can't see where the second one goes to because it's a through hole and it's kind of hidden by here, and then there's quite a few traces around here. My fear is that it's going into this chip, and I think that chip may have failed, but I don't know yet. So what I'm going to do is, I mean, I don't even know if I'm tracing the right thing. I'm just thinking we've got power this side of the board, but we don't seem to have any power on the switch because when we turn it on, it's not doing anything, and it should short to ground when we turn it on. That's how it knows to turn on. So I'm going to unsolder this using my desolder station, and then I'll physically be able to see on this side where that pin goes to, and then maybe, for example, it might go down to this transistor, and you never know, it could be a faulty transistor. If it then goes into here, then I suppose what I need to do is I need to try to find out where this chip is powered from. If this chip is getting power, but yet when we press the button it's not turning on, that says to me that chip's faulty, and then, you know, I need to look into that chip. So yeah, that's what we're going to do now. Right, let's zoom in now and see if we can work out where this contact is going. From here, going to here, and then we lose it when it goes through here because obviously the meter gets knocked out of continuity. But look, can you see from here, little trace from here to here. So from here, it goes to here. And then from here, it goes to here. There. What's interesting, it's also coming up here as a 2 ohm short. So let me zoom out so you can see my meter. Let's just put it purely on ohms. Now, this big pad here, I'm presuming this is ground. From here, it goes to this little thing here. So if we just use that little wire there as a ground, it's kind of sad, I don't even really properly know where the grounds are on this board. It's really confusing me, but I'll tell you what, will it go to the grounds, will it go to the negative of the capacitor? Because this is on the DC side, isn't it? So let's see if it will go to there, to there. Okay, and let's see what reading we have. So that should be a full short. Yeah, it is a 1 ohm short. Right, okay. So from there, it goes to this little bit here. So we should have, from here to the negative of here, a full short. Right, so that has to be ground. Now, if I go from here to this side of the capacitor, so basically from where I'm going here now, it goes down to that side of the resistor. But look, that side of the resistor is a 2 ohm short. So it's not a complete short, but look, that side of the capacitor is 2 ohms. It seems quite it's nearly a short, isn't it? And that side of the capacitor is the short. So basically this capacitor is giving me like 2 ohms. And also, does that go to, there's a transistor here. I just want to see if it goes to the transistor. Right, so it's coming up here. What ohms is that? See, that's a short, that side there. And then we've got a 2 ohm short there. I'm wondering, and I wonder if the middle of that transistor, I wonder if the middle of that is the ground. Let's go to diode test. Let's go to each of the legs on this transistor. So red in the middle. So we've got a short there. No short there. Let's swap over. That doesn't look right, does it, on those two? You see there. So that, if we go to ohms, that will be a full short between these two legs. Well, the 2 ohm short. So is that where the 2 ohm short's coming from? I think. See, maybe it's not turning on because it's been pulled down to ground. Let's undo this transistor. Okay, well, that's given us different readings now, isn't it? So I think that looks to be okay. Let's see now. Have we still got that weird short? Yeah, we have, haven't we? I think we're going to have to do a bit of voltage injection. I'm going to put a wire onto here, and I'm just going to put 1 volt into the circuit and see, you know, whack up the amps, see if anything gets warm. You never know, there might be a faulty capacitor somewhere that's dragging it down. I'm thinking at 1 volt I'm not going to harm anything. Okay, so this is going to be my ground. Let me just turn on my bench power supply, get it down to 1 volt. And I'm going to whack up the amps. Right, so I'm at 1 volt now. 10 amps, why not just leave it at that? Okay, so now I'm going to put this on here. So this is going to be my ground. We are drawing 1 volt at 4.7 amps. So 1 volt, so what's that, about 5 watts? Would that be enough to heat something up? Oh, sorry, hold on a minute. No, that's not, that's 450 milliamps. What am I talking about? I don't think that's going to be enough to get anything warm, is it? See, I don't know what side of the circuit this, what voltage this side of the circuit is going to be taking, you know, for the on and off switch. I don't know what drops the voltage down, because up to here we have like 300 volts. I can't see what it is that drops it down. Right, let's up it. That's just broken. Let's up it because I'm thinking it's going to be, what would it be? Would it be 3.3 volts at the on and off switch? I think we might be safe to up it to 2 volts. Mind you, what happens if the chips are going to be 1 volt? See, I don't know what the chips are running at, do I? Tell you what I'm going to do. Let me get my FLIR cam and then turn it on and see if I can see anything that's getting warm. So I'm just going to leave this on at the moment. Right, well, according to that, it's this chip that's getting warm, isn't it? It's really playing up. Right, okay, well, it seems to be coming from this side of the chip. Let's spin the board over. Yeah. Where it's lighting up, there is no components. It's not exactly super hot anyway. Do you know what? I'm going to put more voltage into it. I'm going to go up to 1.5. Right, 1.5 now. It's drawing 0.6 amps. Well, there's no components there. That is just the edge of the chip. Okay, well, you know, that chip's definitely different than everything else, and it would sort of make sense that it might be a chip problem because it just stopped working. Yeah, I can feel that warm now. I can actually feel that warm with my hands. Oh, that's a shame. Yeah, really getting warm now. I'm going to zoom in with some IPA, just in case it's something next to it that I haven't spotted. So let's do a bit of IPA here. See if we can see where it's burning off. Yeah, look, the middle of the chip. And that's, of course, that's just normal. And it's just heating up because the chip is kind of getting, you know, power from here. What makes it harder is because there's so much conformal coating, everything just looks really wet anyway. I think that chip's failed. Right, let me Google what that chip is. So it looks like a 104BAA. Okay, so I've managed to find it online. That's the write-up on the chip, and it's got 8 pins on each side, so it's 32 pin in total. I found the pin out, and basically you got the ground on the left, 1 pin in, and then the voltage in on the right hand. So this is the voltage in here, and that's the ground next to it. I'll show you that in a few minutes. Voltage in is between 1.6 volts and 5.5 volts, so I only put 1.5 into it, so it should be okay, but I think it's blown anyway. And it's a microcontroller unit. Now it's a Renesas, which I recognise from, I think it was the PlayStation 4. Unfortunately, it doesn't actually make any sense to me. I think this is the brains of the operation, so maybe this is a thing that sorts out the timer, because you can have a timer on this up to 9 hours, and also things like the oscillation and the speed. So I think this is probably the thing that controls everything. I have found the 32 pin out, 32 pin out. Let me just get that for you. Do you recognise my all-in-one? That was a thing I fixed months ago, or years ago now. Still working. Now all the other pin out bits don't mean anything to me. 32 pin, here we go. So this is a 32 pin here, and you can see it is labelled up with everything around it, but it's just, even when I find the key for that, it still doesn't mean anything. But I definitely recognise this here. Can you see the VDD and VSS? So VDD is going to be voltage in, and this is going to be the ground next to it. Now let me go onto the overhead camera, and I just want to show you where they lead to. Now the problem is it's kind of hard to trace because obviously the shorts are coming up all on that area, but if we go to the middle one here, we know that a short's going to be like 1 ohm roughly, or less, or a tiny bit more on my meter. So there you go, you can see right now it does vary with my leads and stuff, but that's a full short. So if I go onto the middle one and go onto VSS, which is the second one along here, you will see now. There you go, we've got a full short there. But now if I go to the green wire, which was this one here, and if I go to the first one along, you will see that we also have, 1 second, a good contact, we also have a full short. So I think that this transistor is then going on to feed here. I haven't actually followed the wires round, but we've definitely got full continuity there. But look, if we go between the ground and here, I mean, we've got a 2 ohm, that just doesn't seem right. We've got a 3 ohm short, I don't think that's right. And if we go between these 2 pins, we will also have our 3 ohm. There you go, 2 ohm, yep. So I don't, that seems very low. I understand on computer chips and stuff, they're designed like that, but on a chip like this, then it doesn't quite seem right. So what I'm going to do is, I'm going to put it back together, and I'm going to see if I can measure, because I can go either side of this capacitor here, and I want to see, I'm going to clean it up first of all, I'm going to go either side of the capacitor. I want to see whether or not, when there's power going into this, I'm going to solder this back in as well, whether or not we do have voltage into this thing here. Okay, so I've got the transistor back on, and I've soldered this back on as well, and I've just connected up the motor, and the main's coming in. I haven't got the fan going away. It should still turn on even without that, I'm pretty sure. So let's plug it in now and see if we have anything different. No, right, okay, so it's still not turning on. I know you can't see, but it's not. Let's see if we have voltage on these two pins. So I'm going to go on the capacitor. No, we don't. Okay, so that would suggest why it's not turning on. So what I'm confused about is, we haven't got voltage there. Is that because it's being knocked down? Or is that because this chip isn't being fed with the voltage and that's why it's not turning on? I don't understand where the voltage comes from on here. And does it go to the chip first or does it go to the transistor first? Don't know how I would prove that. I suppose I need to find out what's causing the low voltage side, because we know that this side is high voltage. What's causing the low voltage for this chip? Maybe that's not working. But saying that, we still have a short. I don't think that seems normal. I wonder if I was to input 1.6 to 5.5. I wonder if I input voltage here, would it then come to life? Should we try that? Because then that might give us a clue whether the voltage is being dragged down by a faulty component or whether there's a component that's just not providing the voltage to here. Let's try that. I'm going to unplug it. I'm just going to solder on a couple of wires to those that capacitor. Right, okay, so let's start with 2 volts, I think, on the bench power supply. So what I'm doing here is I'm bypassing the part of the board that puts voltage into the chip, because I don't know if the chip's not getting power or whether the chip's dropping the voltage down. So I'm physically going to put voltage into the chip on the VDD and the VSS pins from my bench power supply. Then if it all comes to life, we know it's the fact that the chip isn't getting the correct power. If it still doesn't work, that says to me that the chip is internally shorted, which the FLIR cam kind of suggests it is. And then we know it's nothing to do with the power supply feeding it. We know the chip itself is faulty. Now, is it all going to explode on me? I don't know. Okay, let's be brave. Right, I've plugged it into the mains, and I'm at 2 volts. This one here is my negative. And now this one is my positive. Let's just hit this on here. Let's try and turn it on now. No, but it is drawing 2 volts. It's drawing 0.4 amps again. But that's because of the short, isn't it? So we've still got nothing here. Right, let's up the voltage a bit. I'm going to go to 3 volts. I'm at 3 volts now, it's at 0.7 amps. And we still don't have anything going on here. It goes up to 5.5 volts. Let's go up to 4 volts and call it a day at that. Right, 0.9 off an amp. Yeah, there's still no display here. I know you can't see, but there's no display at the front here. And still nothing's happening. Just want to try to turn it on here. It's making a weird noise. The motor's turning, look. This motor's turning now. Can you see? When I went to turn it on. But we still don't have anything here. Okay, let's see now if I go to turn it off. Right, the weird thing is now, it's not drawing any amps on my bench power supply. Oh, it's saying 5 volts now. Sorry, my bench power supply is saying 5 volts. I never put up to 5. Okay, let's try to turn it off. Obviously, I'm not putting my fingers near it. These are all insulated. No. Right, so it's just basically oscillating without doing anything. So let's unplug it. And I'm curious why my bench power supply is reading 5 volts. Right, now it's gone down to 4 volts and it's drawing 0.043 off an amp. Okay, let's turn it on now and see if it starts doing that oscillation. Yeah, so I must have blown something by doing this maybe. It's doing the oscillation now. Let's see. Be interesting to see if the motor's plugged in, whether or not the fans are actually spinning. Should we do that? In a way, I might have kind of made a working fan, but you just can't. You can't control anything. Right, I'm going to plug it in again now. I'm holding on to the plastic here, so I shouldn't get a shock. No, just oscillating, nothing happening here. It's a shame that controller can't be bypassed, but then all that's going to happen is it will probably just come on full belt. You know, I'm sure you could probably make it work where it oscillates and comes on full belt all the time, but that's, you know, you want control. Right, okay, so I've unsoldered that from there now. Let's see if the oscillation happens now when we plug it in. Yeah, it does. Oh my God, we've got 2 lights at the top now. What? We've got 2 lights at the top, look. See the 2 lights? What's that about? Right, let's there's still nothing's happening. Isn't that weird? So there's more life now. Right, I've convinced myself that that little chip's faulty. So by me putting voltage into that chip, I've somehow created some new pathway or something, haven't I? Just going to hold it down for ages. Right, this is interesting, but it's still no, I think it's just acting weird. But basically, the motor will turn one way, and then if I hit the button, it will turn the other way. Obviously, I've got to be incredibly careful because this is mains. But can you see right now that motor is going clockwise? Yes. Right, now watch this. Hold on 1 second. There you go. Can you see now? It's going counterclockwise. Right, let me do a little bit of research online, because maybe I can buy this board, or maybe it's a common problem and other people have already discussed it. Okay, I've been having a good look online, and unfortunately I can't buy these boards. I was hoping I'd be able to buy one and then I would just be able to get the fan working. Bit of a failure because it's just replacing it rather than fixing it, but still the product at the end of the day would have been working. These are not on eBay. I thought there would have been loads of people breaking these, but no, not the case. So eventually I'm sure I will be able to get this working once people start breaking them and then selling off the motors and the casing and this, then I'm sure I'll be able to probably get it for £15 or £20 eventually. But I think they're a little bit too modern for people to be breaking them yet, because I suppose they're either getting sent back to Dyson or they're getting fixed. Now, I had a look to see if anybody else is having, you know, similar problems, and there's very little information about these online. But luckily, Buy It Fix It, who I mentioned on the Amiga Watch video, I'm not even sure if I've released that one yet, but as of when you're watching this, I don't know which one will come first, but he's done 2 videos on Dyson fans, and between both of them I learnt quite a bit. Now, bad news is that this Renaissance chip here is linked to this little programming port here, and you see by the access thing here. So even if you were to be able to buy one of these, then you're not going to have the software or firmware or whatever to put on it to make it work. So that's not an option. What he did say, which was interesting, is, remember I was worried about how's it getting the lower voltage to power this when all this is higher voltage. This here is a little switch mode power supply, this little chip here. And I think that together with the coil, this circuit here, is then reducing it down to whatever voltage this needs between 1.6 volts and 5.5 volts. So I did learn a bit, but it's still not actually going to help me fix this one here because his one had different faults. So what I want to do is I want to know, I'm sure that this chip is faulty, but what I want to know is if I take this chip off, will I then have between 1.6 and 5 volts feeding it? If I do, then I can safely say that this chip is not working because it's getting the correct voltage. But if I'm not getting that voltage there, then maybe there's a slim chance that this switch mode power supply thing here, this chip has gone faulty, or maybe there is still a capacitor drawing it down somewhere. But annoyingly, what's different now is, remember before I had that 3 ohm short on it? Well, now that's gone. So if I go to ohms here, and if I go over the same capacitor, you see now it's completely gone. So when I put in that 4 volts into it, I seem to have cleared, I seem to have broken that short. So if I was to go onto the same ground that I had before, and if I go onto here, can you see this? It was this one here, wasn't it? So that is the actual ground side. Or is it this side? Right, okay, so that was the one that was like 2 or 3 ohms before, and this one is the actual, yeah, so that's the ground side. So even that tiny little capacitor now is not showing that fault anymore. And if I go between the 2 legs of this transistor that had the 2 or 3 ohm short before, can you see now it's completely open? So it's different than it was before, but I've just plugged it in and it's still doing that weird spinny thing. So let's measure it now and see what it's doing. See, can you see? It's spinning all the time now, which it didn't do before. Let's see if we have any voltage there now, because that short has cleared, but it's still completely unresponsive. So I'm going to take the ground from here, and let's go to this side of the capacitor. There you go, 5 volts, and that's the ground. So you can see now, probably because I've put my 4 volts into this chip, I've completely blown it open. And now if I go onto that capacitor, 5 volts. I wonder what we're going to have here. Let's see if I can test this here. Transistor. Yeah, 5 volts. So you see now the circuit itself is okay. I've done something to that chip to blow it open. And because of that, now we have a display and we have the motor working there. So it's doing more than it did before. So it's going the other way now. Do you know what? This is all low voltage here. I'm going to do something silly. I'm sure that chip's blown anyway. I'm just going to go around the edges of this chip to see, because this is all low voltage here. I just want to see if anything different happens with the display or with that. Or even, should I plug in? Let me plug in, 1 second, I'm going to unplug it. Let me plug in the main fans, just in case it causes the fans to come on. It might be quite exciting. I'm only doing this because I'm sure that that chip is faulty. Obviously you shouldn't be shorting legs of the chip that are not designed to short. Right, let's just see now if anything comes to life. Right, so we have 77 written on there. Obviously this will only work if the 2 pins next to each other need to be short. So for example, if there was a ground next to, for example, a reset pin, then it might do something. No, nothing. Oh, there we go. So it's when I go onto the power ones. So right now we're clockwise there. Still clockwise now, it's gone off. Now it's anti-clockwise. Yeah, so I mean, we kind of prove that this is the chip that's controlling this and that, and I presume here as well. Yeah, look at that. Whee! Right, okay. Interesting. Oh, it's a real shame. I'm sure that chip is faulty. So look, there's no point in me taking it apart. There's no point in me taking it any further. I'm positive that that chip is faulty, but could somebody explain to me why when I put 4 volts into it, if for example if it's designed for 5 volts, why when I put 4 volts in, did it fail? Is it because there was, is it because it was internally shorted and I physically put 4 volts in, so now I've kind of blown that short away. Still not going to work because now it's more a no contact fault rather than a short fault. Is that's what's happened? Did it short originally? I've now blown that short open and now it's a no contact fault. Yeah. Right, I've put it all back together so I can sell it back on eBay and just have it down as untested. So, I'm only joking, I'd never do that. What's interesting is I thought there was going to be a problem with the oscillation because the motor just kept going round in one way, didn't it? But look, that is working so smoothly. I kind of feel good that we managed to get lights. How desperate is that? So desperate for a fix that I'm pleased that it's oscillating and we got lights, even though it's completely uncontrollable. When I press that now, it doesn't seem to go in the opposite direction. Oh, it does, look, yeah, sorry. Yeah, okay. Oh, do you know what? I really want this one to work. I've had a look on eBay. There is somebody selling another one, but it's about £130. And again, it's no power. So I'm thinking, I wonder whether that microcontroller is a weak spot. Look, put it down in the comments. Anything that's relevant, whack it down in the comments. And yeah, I think it'd be quite a few years before you see this one working again. Such a shame. I wish there was a way you could kind of bypass that chip and just, even if you just had it to come up at speed 1 or speed 2 or something, you know, because the power side of it's okay. It's just the control side of it which is not. Anyway, such is life. See you soon, everyone.
I went out and tried to cut a pine tree down, fell through the ground like Alice. Oh, what a sound. This must be a nest. I got rocks and sticks against my chest. I'm Alice. Dear Queen of Hearts, I'ma grow you white roses so you can learn to be kind. Tell King of Hearts to arm all his forces so you can learn to be